Okay, a few more things here. We can actually already create some rhythms here. It doesn't have to be just melody. That's how I would do it. I would change some of the elements in our array to zeros, and then I'm going to route the output of our tabwrite object and say that we're going to use the Moses object. It outputs everything that larger or equals to its argument out of its right outlet, and everything that is less than its argument out of its left inlet. So we're going to, let's say, I'm going to show you, let's say it's 50 now, and as you can see, everything that is less than 50 comes out of its left outlet, and everything that's larger or equals to 50 comes out of its right outlet. And now we want to have everything except for the zeros here. So we just say it's going to be 1. Everything that is larger than 0 is going to come out of its right outlet. Let's see how it works. There is also like a more complex way to do that. I would do something like that. We can use the spigot object here that only outputs whatever comes into its left inlet if its right inlet equals to 1. So yeah, now it works. No, it doesn't. We can actually put a toggle here. So we're going to use logic again, and we're going to say that if it's not equal to 0, we're going to let it pass through. And if it's equal to 0, we're not letting it out. Let's see how it works. Yeah, both spigot and Moses are very useful for stuff like sequencing. I'm going to go with spigot now. And the other cool thing about arrays is that you can also store audio information in them and then read them, and it actually doesn't matter. You can also write something like this into array and then you use like a tabwrite object for signals to read from it. I will show it later when we really get into sampling, but for now let's create an oscilloscope for our sequencer. And yeah, one last thing here. I want to reset our sequence whenever we restart the metro object. Okay, so now we're going to create another array. Let's give it the size of 48 samples, so we can fit 4800 elements in there. Let's use polygons here for it to look nicer. So we have our second array here. And now we're going to use the tabwrite object to write into it. We have to tell tabwrite to write into array 2. We connect it to our synth. And now we have to send our tabwrite object a command to write. Well, we can send a bang. Then by default it's going to just start writing into the array and finish when our array is full. Now we're going to create another metro object. We're going to set it to 100 milliseconds. Yeah, the reason for that is we need to make sure that array has enough time to get filled up before the next bank. So since we have the sampling rate of 48,000 samples, that means that we have 48,000 samples in 1 second now. So in 100 milliseconds, which is 1/10 of a second, we are going to have 4,800 samples. Hope that makes sense. Now we're going to turn this on. There is no sound. That's why it's still blank, but now we turn the other metronome on. And as you can see, here's our sawtooth wave. Well, yeah, that's it. Let's tidy up here a bit. First of all, I might want to turn our oscilloscope into a subpatch so it doesn't take as much space. And then cut our tabwrite. Yeah, then we're going to add an inlet, and then we're going to add a second inlet for our signal. Let's put it like this. Then that's the cool part about subpatches. You can like make quite decent user interfaces and then reuse them. Like if you create an abstraction that is going to be a user interface, that would be cool. So yeah, we go to, I should make it more clear now. In the subpatch now, I'm right-clicking on the canvas itself. I go to properties, and this is our canvas properties. And first of all, we want to tick graph on parent. This is our square where we're going to fit our array. Now we have to define the size of our square. So I'd say it's going to be 220 by 270. This is size in pixels now. I guess I should mention that. So now it's going to fit. Yeah, let's see how it looks from the outside. Now, as you can see, that's our subpatch name that overlaps with our array name. So we can go in here and tick hide object name and arguments. Now it looks better. And now we can do this. Yep. Now we have an oscilloscope. Another thing about setting up melodies into arrays, I'm going to show you another way to do that with our synth object and our MIDI keyboard, the thing we worked on. I'm going to move this aside for a second. Then we're going to use note in. Then we're going to do strip note on that. Now we send the pitch information to our synth. I hope. Yes, we do. And we want to send it to the table as well. For that, we're going to use the tabwrite object. We're going to call it array 1. As you can see, it's a control object, not a signal object. And it has 2 inlets now. The one is going to be the element we're going to write into our array, and the other one is going to be the position. Whenever we press a key on our keyboard, it's going to cycle through the whole array. We're going to make a counter, obviously. Yeah, mode 8. Sorry, mod 8. Let's give it a reset message. Now, number box. Sorry, I do realize that I spend a lot of time just moving things around, but I can't help it. It has to be tidy, at least my idea of tidy. Sorry for that. Then, yeah, gonna make extra sure that we output those notes into our table. And now, whenever I press the MIDI note, it cycles through the table and sets the pitches in the table. Let's see how it sounds. I mean, it probably sounds weird. Yeah, and let's connect it to our oscilloscope. And I can change it in real time. Yeah, well, that's silly, but it works. Alright, one last thing I want to show you is how to get MIDI messages out of Pure Data into other software. So we're going to send our MIDI messages to a drum machine. I load it into DecentSampler. There is no specific reason for that. It's just DecentSampler is free if you want to try it out. Also, the libraries are free and it would be easier to deal with than VCV because it's just samples, not patches. So now I control it with my MIDI keyboard. And the idea here is, first of all, to send out MIDI messages to DecentSampler from Pure Data. And the other thing is I want to be able to actually write my patterns into arrays with my MIDI keyboard. I know it might look confusing now. I tidied everything up a bit and added a lot of new stuff. Well, first of all, this is the oscilloscope we made the last time, and I decided to combine it with something similar to the output object we used. Yeah, we have the mute button here, our toggle, and this is our volume button, and this is the table we're writing sound in. Next thing, I put our counter into a subpatch, and now you can set up the tempo in beats per minute. I did it with a little message here. I think it's a nice way to do because you obviously have to send the new tempo into the cold inlet, and then you have to bang it, and this saves more space. You just send it as a message. So you say that you have to divide 60,000 by whatever comes into the inlet. The other thing here is that our pattern is going to be 16 steps long, so like a 4/4 bar with 16th division. Then the other thing, we can actually name our inlets and outlets. It's very helpful in case our patch gets really big and messy. We want to keep track of what comes in where and comes out of what. I guess that's a weird way to put it. Never mind me. So yeah, now we have our counter on, which sends signal to a metronome object I decided to make. It's also made out of all the objects we know and love. First of all, here's the spigot again. This is how I turn it on and off. Then the idea here is to, instead of 16th notes, only bang quarter notes. Like if we change the mode to 1, now it's going to output 16th, and then you can change it to 4. and now it outputs quarter notes. Now this we actually don't need. So this is a little synth again, the oscillator and the envelope. And then I wanted to change the pitch to mark the beginning of the bar. I think that's all of it. Yeah, let's change it back to. Okay, then the next thing, I want to have two separate layers. One is going to be our kick and our snare. So, and the other one I'm going to save for hi-hat. Here's our tabwrite object. There is a bunch of things here. Now it's going to receive numbers from our counter. Like if we connect it here, you can see it starts counting. Then we can choose between two arrays in which to write. Like, let me demonstrate. Yeah, something like that. That was second array, and if we change here to array 1, we write into the first array. One thing to make sure about that, if you send to a message box symbols, you have to specify that it's a symbol. Same for the set message. That's actually how we set to which array to write. We tell it, write set array 1 instead of this variable. And the last thing, we can actually reset the array to be all zeros that we do with sending constant 0 message to one of the arrays. Again, I can change it to array 2 here and then click reset again. There is generally a bunch of really useful messages you can set to arrays. You can check out the help file, but yeah, we're going to need this one. I'm going to try to bring the rhythm I want to the metronome and then write it into the array. And probably I'm not going to manage it from the first try, so that's what the reset message is for. Now, yeah, that's our note in, as from the previous patch. Let me try this. So, let's see. First, we have to make sure the signal is going out. We are going to create two subpatches. It's going to be called PD MIDI 1, and we're going to copy it and make a PD MIDI 2. So there is a noteout object. And what you need to know, it sends MIDI messages the same way notein outputs messages. So the first one is our pitch, then comes velocity, and then the channel number. I'm going to do it the following way. This is actually going to be the second variable. I'm going to disconnect our notein for a moment, and then I'm going to do the following. Let's see. So we need a MIDI note, which is we're going to receive from our tap play object. As you can see, it's same as before. We read from the table, then everything that is equal to 0 we do not output. Now that's our MIDI information, and then again, as you remember, note in and out messages always come in pairs. You need the note on message and note off. Let's do this. Trigger bank float. Now let's specify the length of our notes, which is going to be, let's say, 50 milliseconds. It's just a random number. And now we're going to use a, delay object. Well, first of all, we send our velocity on. Let's not make it too loud. And now we use the delay object. So if you click on it, there is a help file. Basically, the right inlet is the delay time in milliseconds, and the left one just receives either bangs or also messages with delay time in milliseconds. So yeah, let's say we do this. Yeah, now it comes 1 second later, and you can do the same by just using the message. Let's say 500 milliseconds. Yep. That's the one, and we're sending this 50 milliseconds delay into our delay object, and then it bangs a 0. Now we have to pack our pitch, and sorry, I have to move things around again, so I sleep better at night. Alright, let's make sure that we have all the outputs set correctly. Yep, it should be IAC driver on the output of your data, and for the DecentSampler options, audio MIDI settings. Yeah, we have it ticked, that box, so it should work. Let's see if it works. I have no idea which pitches are what here, so let's try. This is our bass drum. Apparently it's 35. Let's try 35 here, and it should work. Yeah, it actually works. Now, since I made a mistake and I've written everything in array 2, let's connect it to our second outlet, which is our array 2 output, and see how it works. So let's see how in time this is. Okay. That actually worked pretty well from the first try. I'm surprised. And then, yeah, we're going to just copy it. Apparently now this is MIDI 1 and now this is MIDI 2. The other thing I want to do is to make a switch between writing and reading, and I'm going to do it the following way. Let's connect this back. Let's make sure it actually writes into array 1. We are going to create a list here. The first message on the list is our counter, and then we want to control to which tab player, tabwrite we're sending it. I'm going to create a toggle here. Now I'm going to swap them around. We already know how to do that. Then we output this. Yeah, as you can see, it works. Now, if you remember, we used select object multiple times before. There is a similar object called route, which basically does a similar things, but as you remember, select only outputs bangs, and unlike select, route outputs the parts of the message that come after the element of the list we're routing. We could also do that with Moses, but that's gonna look a little more complicated. Yeah. Now we have tabwrite activated. Let's record some hi-hats. Could be better. that should do it. Let's see how it sounds. And now we can speed it up, actually. Well, no, this is slowing down.